Good morning, y'all. Gina Brown here, Miss Brown, your 8th grade science teacher, or maybe your 7th grade avid teacher. So, y'all, it's Friday. What? I'm calling this our first real week of school because last week was just so much fun. I mean, this week was fun too. My class is always fun. But like last week we were doing like get to know you stuff. So this was our first like real week diving into curriculum. I think y'all killed it. So as I was kind of thinking about the week, I thought that I hadn't really recorded anything about content. I'd been kind of recording Canvas stuff. So what I wanted to do was I wanted to record me talking about my man Harry Hess and my man Alfred Wegener. Harry Hess is a new name. I just threw that one out there. Sorry. And so this way you'll have it to watch before you take the quiz, while you're taking the quiz. Because remember, it's an open journal, open resources, not open internet, but like open journal, open resources. Check this out. Got a little cityscape going on. I like this. Okay, y'all. So I'm going to have you follow along with me, and I'm going to go through a slideshow that I popped in the quiz instructions page, and then I'm going to pop this video of me in there as well. And then I've got this cute little website. So let me hop over here to show y'all what I'm talking about. Okay, so this is let me go back home so I can show y'all exactly how you get where you got to be. Because I still have some people kind of asking questions, and y'all, I'm not playing. I'm not telling you next week how to get here. So it's week 3 of school. Okay, we got to be independent learners sometimes. So you got to know how to get where you got to be. So you hit that week 2 module. Next week it will say week 3. And then we're going to go down to Friday because that's what the day is today, Friday, August 28th. So this first button, I put the little brain emoji so that way it kind of indicates that we have an assessment coming. So here's what you're going to do. You are going to kind of check out this page. If it ever loads. Here we go. And what I have here is I have this slideshow for you. So it says prior to taking the quiz, kind of check out this slideshow. And then below this slideshow in this open box is where I'm going to put this video right here. And then I also have this website. So whenever you see this little box with like an arrow, that means that it's live linked and you can click it. So let's chat, y'all. Okay, so let me open up this slideshow. Y'all, I don't know what it is. I told you every time I record, my face itches. It's the weirdest thing. Okay, so y'all, I'm digging this. Usually I do like a beachy theme, but I got to get my city folks some love too. That's pretty cool. I like it. Okay, so continental drift theory. So I got this slideshow from Kessler Science. Chris Kessler, love him. Thank you. So he is an amazing educator that helps us out with giving us some great resources. So he made this slideshow. I'm just going to chat with you about it. Can't take credit for something I didn't do. So, essential questions. Who's Alfred Wegener? Say it with me. Alfred Wegener. Remember, he's German, so the W's like a V. What's the historical evidence that supports continental drift theory? So, I'm going to refresh and remind you about the things that he had evidence for to say, yo, these continents are drifting apart. I know it. I don't know how, but I know they are. And then the third one is what causes the movement of the continent. So that was the piece that he was missing. And people didn't believe him because of it. It wasn't until after his death when my other man, Harry Hess, came along that they were like, oh yeah, Alfred Wegener, you were right. My bad. Sorry. So we're going to talk about Alfred Wegener, top left, GQ model. Takes a great picture. I mean, come on now. And then what's continental drift theory? When the continents drift, when the continents move, the plates move, just like Tokyo drift. Remember I said they kind of drift apart. And then what's Pangaea? That supercontinent when all the continents were once together 250 million years ago. And then they slowly, like an inch at a time, drifted away from each other. And remember, Pangaea is spelled kind of weird. It's Pangaea. A lot of people forget that first A. And then what are the 3 pieces of evidence? We're going to break it down to the 3 pieces of evidence that he used to support his theory of continental drift. Alfred, Al, check out that picture. It's like, there's only like a few pictures of him. And I would be happy if I was Alfred Wegener and this was the picture that was circulating. Because, I mean, if there's only going to be a couple pictures of you, that's a great picture of him. Come on now, right? Okay, so Alfred Wegener, he was born in 1880. He died in 1930. So remember, he did this theory around 1915. So it wasn't widely accepted until after he passed away. So he proposed his theory of continental drift. The idea is that the continents were moving apart from that single supercontinent, Pangaea. So even though there was all this evidence about fossils and rock evidence, other scientists didn't believe him. He was like an outcast. He wasn't friends with them. He didn't want to hang with them because he's like, I know this is what is happening. Why doesn't anybody believe me? So yeah, people didn't believe him. It makes me feel bad. Because he couldn't explain how the continents moved. Like, so a lot of people, in order to believe what you're saying, they need to know how, like why, how. And he couldn't say it, but he knew what happened. So it wasn't until the 60s, 1960s, that continental drift theory finally became accepted. And then it was known as a part of the plate tectonics theory. So continental drift theory came first, early 1900s, and then later 1900s, once people got evidence of why this happened, then it kind of moved into the plate tectonics theory. So here's Pangaea, that supermass. So you notice we have Eurasia, which is Europe and Asia, North America, South America, Africa, Antarctica, India, and Australia, and they're all kind of smushed together. So that 250 million years ago is what our world, what our Earth looked like. And it was called Pangaea, and it was a supercontinent. And it began to break apart about 175 million years ago. So 250 million years ago, it looked like that. And then about 175 million years ago is when it started to drift, Tokyo drift style. Ooh, check this out, y'all. I'm really digging these scenery things I get from YouTube. So there were probably other supercontinents before Pangaea, but we just don't know. So who knows? Maybe it looked even a little bit more different. Maybe it was squished together even more. We don't know. And the Earth's continents have been continually breaking apart and then coming together. So they break apart, but then the Earth's a sphere, y'all. It's not flat, like whoever that crazy rapper was that said. So like they drift apart and then eventually they're going to come together on the other side. Like it's not an infinite amount of space for these continents to play around in. So when they break apart, eventually on the other side, they're going to come together. And when they come together is when these mountains form, when two continental plates come together. If a continental and an oceanic plate come together, the oceanic plate subducts. We'll learn about that next topic. And that's where you get different land features. But converge, boop, diverge, and then transform. And y'all, those plate boundaries aren't even on this quiz. This quiz is just my man Alfred Wegener and continental drift. So topic 2 is when we're going to talk about all these boundaries and all this moving around. Okay, cool. So Triassic 200 million years ago, you had Laurasia and Gondwana. It was called Gondwana land. Like, what? Where are you from? I'm from Gondwana land. So cool. So Laurasia and Gondwana land. We're not going to talk too much about this because y'all don't need to know the specifics. But once it started to break apart Pangaea, then these two supermasses were called Laurasia and Gondwana land. And then they roughly formed the northern and southern hemispheres. So this is what we need to talk about. So let's talk about this evidence. So you need to justify our claim with reasoning. CER, claim, evidence, reasoning. His claim, continents drifted. This is the evidence. He didn't have the R. He didn't have the reasoning. He only had the C and the E. So fossil evidence, y'all, we talked about this when we did our puzzling Pangaea. We noticed that there were animals that were roaming, died, buried, fossils, broke apart. These fossils match these fossils. Mesosaurus, Signathosaurus, those things can't swim. So they were thinking, how on earth did one get here and one get here? Well, because they used to be connected. And y'all saw when you did your little Pangaea that those little bands of fossils stretched right across the two continents after they had broke apart. So that's the first piece of fossil evidence. Second piece, y'all, it's a big puzzle. Like, talk about fun. He literally sat there, just like Dmitry Mendeleev sat there, and you'll learn about later, with elements and placed them to make the periodic table. My man Alfred Wegener sat there with his continents and was like trying to place them together, and he's going, yo, this one fits right up in here, perfect. And that's how he realized. And then when he realized they fit together, that's kind of where that fossil evidence theory came after, because then he thought, hey, if these fit together and these fossils match up, that means they were once together. And then glacial evidence, y'all. We didn't talk a whole lot about this, so that's why I wanted to do this quick video. When those pieces moved, they moved from maybe the equator, which is hot, up to the poles, or vice versa, from the poles down to the equator. So what they noticed was that there was glacial evidence on continent pieces that were by the equator. It's too hot to have glaciers at the equator. So how are these? There are these scrapes, these called striations. So if you think about it, I can have throwbacks to when I'm pushing a chair across the kitchen floor and my mom and my dad are like, no, and I'm scratching up the floor. Well, that's what the continents, that's what the glaciers did on the continents. When these big old ice masses move, because they kind of melt and they start to move, think of an ice cube on a table. Once it starts to melt, it kind of starts to swish around. Glaciers do that, but they're huge and they're heavy and they're sharp. So they scrape everything up. And then they realized that there were these continents that had these glacial scrapes on the equator. So they knew this continent piece had to have once been North Pole or South Pole for it to be a lot colder, which caused those glacial evidence, those glacial striations. And then landforms and rock layers, y'all. Same thing with the fossils. Fossils matched. There were also chunks of rocks that matched. So there was pieces of big old limestone over here and then pieces of big old limestone over here. And then not only that, think about like when your room's a hot mess and you're like throwing stuff everywhere. The stuff you throw on the ground first on Monday, your clothes when you come home, boop. And then Tuesday you come and throw Tuesday's clothes. And then Wednesday's clothes, Thursday's clothes, Friday's clothes. What clothes are going to be on the top? Your oldest clothes or your newest clothes? Your oldest clothes. No, your newest clothes, because you took them off and you threw it on top. So Friday's clothes are here, then Thursdays, then Wednesdays, then Tuesdays, then Mondays. So the older clothes are on the bottom, much like older rock is on the bottom. So rock settles, it buries, new rock comes. So they started literally taking like a layer cake. Okay, oh my gosh, yum. It's too early for cake, but I don't care. Like strawberry, chocolate, vanilla. And then they realized that chocolate layer matched the chocolate layer, boop. Strawberry matched the strawberry, boop. Vanilla matched the vanilla, boop. And they're thinking, how did these same rocks form on two different continents? So once again, much like the fossils, they realized they had to have been together because all those rock layers, those cake layers, delicious chocolate, strawberry, vanilla layers matched up. Okay, cool, y'all. So yeah, this is kind of what your final copy should have looked like. It's a little different, obviously, but y'all, look at my little reptiles. This one right here, the Lystrosaurus that I said it looked like he literally just ran into a wall and his face is all smushed up. And then you got your Signathus right here, and then my little cute Mesosaurus, the long skinny one. So those were the three main reptile fossils that they matched up. And then you also have your Glossopteris and where's the other one with the little dots? That kind of summer flora, the one with the little dots at the top. So they noticed that those all matched up. So fossil evidence breaks it down. Talked about this. I'm not going to talk too much because I just talked about it a second ago, but they realized that all these fossils kind of matched up. Same pieces, different continents. They can't swim. And then they also didn't fit the climate, y'all, much like the glaciers. They realized that these really warm climate animals were up top and on bottom, and they knew that they had to have once been towards the equator or vice versa, cold animals in warm spots. Did I skip one? Nope, good. So yeah, palm leaves were found in Alaska. Like palm trees don't grow in Alaska. Sorry to tell you that. So they knew something was up. Next piece of evidence, continental fit. Just like a big old puzzle, the continents, particularly South America, Africa, fit together like puzzle pieces. So you notice right here that little indent, like the in part of the puzzle, and then the out part of the puzzle, and they notice they fit together perfect. And then there was another piece of evidence that continents were once joined. So fossils and then the continental fit. And then glacial evidence, like I talked about this. Y'all, so look right here on that ground, you can see those scrapes. Big old chunks of glacier, heavy, sharp little pieces, like nails on a chalkboard, and scraped it all up, like me pushing a chair across our wood floor and my parents going, ah, glacial striations. So glacial deposits formed 300 MYA million years ago, were found in Antarctica, Africa, South America, India, and Australia. So these striations, scratches on the rock, showed that ice flowed from glaciers from a single point. And then the evidence was found in warmer climates. So look at this chick right here hiking. It looks hot to me there, but there's glacial striations. How does that happen? In a beach, how are you going to have glacial striations? Well, because that continent was once up higher or down lower. Okay, let's move on. So continental drift theory, check this out. Awesome, awesome. Oh, hold on, clicked on me. There we go. So landforms and rock layers, much like the fossils, the landform and rock layers matched up. So the Appalachian Mountains. So y'all, I love my documentaries, and I watched this documentary and they said, stop saying Appalachian. So you got to think of like, it's so silly, but throw an apple, an Appalachia. I'm going to throw an Appalachia. So it's Appalachian. So it's the Appalachian Mountains. And they matched well with the British Isles as well as other places. So same thing, y'all, right here, they noticed that these mountain layers matched up. So not only kind of those rock layers, these mountain ranges matched up. So if you have these mountain ranges that match up that are on separate parts, you knew that at one point they had to have been together to have those mountains form. And then similar rocks and ages of rocks were found on these three continental places, much like I talked about. And then the cold fields up in North America and Europe matched. So there were these big old cold fields, cold mines, and they all matched up. So y'all, let's chat. As scientists, how would you feel if your years of research was discounted, which means they said you were crazy, unnoticed, or completely even rejected? So that happened to many of our great scientists. My man, Nicholas Copernicus, he was the first one that was like, y'all, the Earth is not the center of the universe, not the center of the solar system. I think it's heliocentric. I think the sun's in the center. People thought he was crazy. So, y'all, be dreamers. Think great thoughts. Like, just because you have an idea that other people didn't have doesn't mean you're wrong. Maybe it might mean that you're even smarter or you're more creative or you've got this different kind of a brain. So, even these old scientists, people didn't believe them and they were right. So you do you. You believe what you need to believe. And if you've got a great idea and people don't fall with you, find some evidence, figure it out, and stick with it, y'all, because Alfred Wegener, he was right. Nicholas Copernicus, my man, way back when, he was right too. So we're not going to do this, but we could have had like a little debate. That would have been pretty cool. Okay, so you should be able to, I'm like getting out of breath because I'm getting so passionate about Alfred Wegener. Yikes. It's too early for this, Miss Brown. So can you identify Alfred Wegener and his contributions? So Alfred Wegener, 1915, continental drift, nobody believed him. Historical evidence, fossils matched, continental fit, rocks, rock layers, mountain ranges, they all match. Glaciers were cold in hot spots. And describe the process that moves the continent. So this we didn't really talk about a lot. This is kind of like 6th grade science, but those layers of the earth, you have these kind of convection currents, this hot magma in that asthenosphere. And what happens is, think about like you put veggies or a hot dog in water and it kind of boils and they kind of move and spin. The same thing happens. And that kind of movement creates these continents kind of to move on top. Think of like a big old frozen pond. Y'all are in Texas. I know you don't have frozen ponds. I did back home in Massachusetts. But they break and then they kind of like float around. So that's what happened with the continents. So it was the layers of the earth, that convection currents, that heat that caused the inner part to be liquid, which creates those convection currents, which then allows those plates to move. And that's it for that one, y'all. So this slideshow right here is right here on this quiz page, and you can pull it out by this little button. So you hit this little square with the arrow, and then you can pull it out, save it to your drive so you have it to study. And I will pop my video right here that I'm talking about now. And then this website, I just wanted to show y'all quick because it is pretty cool. So I love this website because it's just a quick review. So maybe have this open as you're taking your quiz. And I put this here so it doesn't count as the internet, because I'm giving you this resource. So it goes over what continental drift is. It shows you what Pangaea looked like, and then the breakdown with Laurasia, and then Gondwanaland, Laurentia Gondwanaland. And then if you go up here to evidence, this is the part that I liked. So they actually show you like what these little fossils, what they thought they looked like. So up here is where that fossil evidence kind of matches up. Here's modern day representation of Mesosaurus, so what they think it looked like. The Signathus, y'all, that looks even scarier than I thought it would look, y'all. It doesn't even look like a reptile. It looks like a bear dog lizard. Bear dog lizard. Ooh, creepy. And then the Lystrosaurus, so right here. So I like this website because it shows you what these fossils that we've been talking about look like. And then right here, the Glostroparis, the modern day representation, that's what they think that Glostroparis plant or tree looked like. And I think that's it. So missing mechanism, we're not going to get to seafloor spreading. So kind of hang at continental drift and evidence. And then I just want to kind of preview to Harry Hess, my other main man. So Harry Hess was the guy that kind of brought it all together. Funny story, which is why I had my submarine Bitmoji in my last video. Harry Hess, so if you read right up here, he was in the U.S. Navy during World War II. So what they did was they sent these submarines down to the ocean floor because they were trying to kind of get a lay of the land. They wanted to see, are there any like enemies coming to attack us? And they wanted to kind of put these submarines down there and send out these sonars, like little bats. And what they ended up noticing was they noticed that they're getting all these pings back, all these pings, and they thought they were being attacked. They're going, yo, what is going on? There's all these other submarines down there. Our radar, our sonar's going crazy. And then they realized that it's pinging off all these mountains underwater and all these valleys and all these hills. And then they started mapping the seafloor, and they realized that the seafloor looked just like the regular ground. And there were these mountains and these trenches, and they were thinking, y'all, how is this happening? And then they started doing research. And that's when they realized that the reason why Alfred Wegener was saying these continents drift was because something's happening with these plates and they're breaking and moving and reforming and crunching and creating all these amazing mountain ranges and trenches on the ocean floor. So it was actually Harry Hess's work, accidental work during World War II, that kind of brought all these pieces together. So this was one of your button websites. So y'all don't forget, Open Journal, Open Canvas. So you can go back to any of those buttons. You can go back to any of my videos. You can go back to your journal. And I am changing the deadline for the quiz to Sunday at midnight, 11:59. Because since I have it on a Google form, y'all, all I have to do is pull a spreadsheet and I can input those grades really quick. Versus, let me show you the other one, my to-do list. Versus this other stuff, top half, these journal pages, I need still Saturday by noon because I got to actually go through your slideshows. I got to grade, I got to comment, I got to enter. So I need Saturday and Sunday to get this entered. But your quiz Sunday night is fine. So here is what I would do, Little Miss Gina Brown in my class. Today in class, tomorrow, I would work on this stuff, top half, getting my stuff uploaded from my journal into my slideshow that I gave you guys yesterday, and then maybe take a break. And then maybe Saturday night, Sunday night, work on your quiz. Because then that way it will give you time to process kind of what you've learned. You can have a little chill break. And then Sunday you can cuddle up, cozy up, and take that quiz. So I revised this. So if you saved this, it should have already revised for you. And I will email y'all and parents just to let you know that top half is still due Saturday at noon. But I'm going to give y'all some grace and have this quiz be due Sunday night because I don't really need to grade it. It grades it for me and I can just upload it. So that's fine with me, y'all. Okay, I hope that was helpful. Pause me, watch me. Y'all, I went back and looked at my YouTube video about my Canvas Google Slides and I saw like 70 something views. So that makes me so happy because I know y'all are watching them. So yeah, 20 minutes. Sorry, I didn't think it was going to be this long, but y'all, I just love talking about science. I can't help it. Okay, bye y'all. Happy Friday, TGIF. Love each and every one of you, and you fill my buckets each and every day, overflowing. Bye, y'all.